Hello everyone, my name is Katie Gamanji and currently I am a senior field engineer for Apple. I have joined Apple last year and my role is to bring Kubernetes and cloud native expertise to different services and teams within Apple. As well, I'm part of the TOC as mentioned, or Technical Oversight Committee within the CNCF or Cloud Native Computing Foundation. Pretty much, I am joining 10 other champions within the industry, and our role is to provide a technical steering vision for the landscape. As mentioned, I have many other roles within the community. Currently, I am on the advisory board for Captain, which is an incubation CNCF project, a status very recently gained. And I am the creator of the Cloud Native Fundamentals course, which you can find on Udacity. It is a free course. So if you have anyone interested in pursuing Cloud Native, I definitely recommend to get this course and understand the fundamentals of how to apply them in production. Today, however, I would like to talk about the bare metal chronicles, and more specifically about the intertwinement between ClusterAPI, Tinkerbell, and GitOps. And to do so, firstly, I would like to start by introducing ClusterAPI. And here we're going to look at how we can have a set of standards to deploy our infrastructure anywhere, mostly in different cloud providers. Then I'm going to focus on bare metal provisioning. And here I'm going to introduce Tinkerbell. But more importantly, I'm going to focus on the union between ClusterAPI and Tinkerbell and how we can provision any Kubernetes cluster on bare metal. And just to sprinkle it up a bit, I would like to introduce GitOps, or where exactly we can use GitOps to further automate our infrastructure deployment. Now, if you look into a production system, you're never going to have one cluster, so you need to introduce template management and automation when it comes to deployment. So here I'm going to introduce Argo CD and how we actually can apply it. More importantly, I'm going to have a demo as well. So it's a live demo, and hopefully that's going to work very nicely. Now, before I move forward, back to the previous slide, how many of you here have heard about ClusterAPI or using ClusterAPI? OK, that's pretty good. There is like a so-and-so. How many of you have heard about Tinkerbell and not the character? Cool. And how many of you are using GitOps at the moment, Argo CD or Flux? OK, so this is a very good show of hands. So you'll be mostly familiar with the topics that I'm going to discuss today. However, I would like to provide an architecture or a solution of how can you combine all of this to get a production-ready bare metal cluster. And actually, how many of you do have a need for bare metal as well? To provision bare metal and clusters on bare metal? OK, in between. Hopefully, by the end of this talk, you'll have more of an inspiration to go bare metal. Now, there is a reason why I'm giving this talk at this moment. And this is because with cloud native maturity and multiple tools crossing the chasm, we have more and more late adopters. However, the difference about these late adopters is that these are enterprise organizations that are very heavily regulated. So they have a strong need to deploy their infrastructure on bare metal and have full ownership of that. So they're looking into full managing and deploying Kube on bare metal. Now, to actually solve these challenging tasks, the picture at the beginning was very different. So if we take a step back 9 years ago, the container orchestrator framework space was very heavily diversified. We had tools such as Docker Swarm, Apache Mesos, CoreOS Fleet, at some point, Kubernetes, and all of them provided a viable solution to run containers at scale. However, Kubernetes took the lead in defining the principles of how to run these containerized workloads. Nowadays, Kubernetes is known for its portability and adaptability, but more importantly for its approach towards declarative configuration and automation. And we can see this in numbers as well. Based on the VMware Tanzu report, State of Kubernetes report, which was released in May this year, 99% of the organizations see a clear benefit of using Kubernetes. The first reason being a better resource utilization for your CPU and memory, and the second one being a better application management, especially throughout the upgrade process. Now, a metric which is going to be very relevant for this talk, 52% of the organizations still have a need for bare metal. An interesting fact is, however, this number is declining from last year. Last year it was 55%, this year is 52%. That's right. However, we still can see that more of the health organizations still have a need for on-premise and provisioning on bare metal. And another thing which is going to be very important for our talk is that we currently have replications of clusters. So 80% of the organizations manage more than 6 clusters. And this is because once you learn Kubernetes and deploy it once, you'll need to replicate that same process for different environments. You're going to have sandbox, incubation that's within the CNCF. You're going to have a QA, you're going to have a staging and a production environment. And of course, you're going to have different regions. So by default, you'll have at least 3 clusters. And this growing community around Kubernetes has been extremely beneficial for it because over time, multiple tools will build around it to extend its functionalities. And we have different tools to focus on runtime, storage, service mesh, you name it. The landscape is very vast at the moment. And this created what today we know as the cloud-native landscape, which resides under the CNCF umbrella. Now, we know that Kubernetes is a pluggable system, and we have multiple tools that you can integrate based on your requirements that you have for your software. However, at the same time, multiple tools were built to bootstrap a Kubernetes cluster. So you might be familiar with some of the tools like kubeadm, kops, kubespray, Tectonic Installer, which now is part of the OpenShift container platform. However, if you look at all of these tools, it's very difficult to find a common denominator. What it actually means is that if you use one tool to deploy your infrastructure to Azure, it's going to be very difficult to use the same tool to deploy infrastructure to GCP. Usually, you'll have to introduce a new tool and a new provisioning process. This is not sustainable. And this is why we require standardization. And that's how ClusterAPI came to be about. So ClusterAPI is providing a set of declarative APIs for cluster creation, management, and deletion across multiple cloud providers. Now, when we refer to ClusterAPI, we refer to C Cluster Lifecycle, which had its first initial release in April 2019. Since then, they had multiple releases and currently supporting a V1 Beta 1 endpoint. And as I mentioned, they currently collaborate with more than 16 providers. Of course, we're going to have the big providers such as GCP, AWS, and Azure. We're going to have support for Chinese providers. And if you try to deploy your infrastructure to China, you'll know it's a very challenging task. Usually, you have to use the tools that are available within that region to ensure that you have connectivity and the full functionality. Now, with ClusterAPI, you have support for Baidu Cloud, Alibaba Cloud, and Tencent, which means you'll be able to deploy infrastructure to China with the same ease as you deployed on the rest of the globe. And recently, we have new initiatives to provision bare metal using ClusterAPI. And this initiative is pushed by Packet, Metal Free, and of course, Tinkerbell. Now, you'll be familiar with this, but for anyone new to ClusterAPI, I would like to provide a fundamental understanding of how it works. Supposedly, you would like to deploy multiple clusters to different regions, different cloud providers. The first thing you're going to need is a management cluster. So this is something which I call kubeception. You need a Kubernetes cluster to deploy more Kubernetes clusters. Now, for testing purposes, it's recommended to use Kind, which is a Dockerized version of Kubernetes. However, if you want to use ClusterAPI in production, it is recommended to use a fully fledged cluster, mainly because it comes with a more sophisticated failover strategy. Now, once we have our management cluster, we require the dependencies installed on top of it. And currently, there are 3 sets of dependencies that we need. The ClusterAPI CRDs, or custom resource definitions, the bootstrap provider, and the infrastructure provider. Now, ClusterAPI introduces 5 new custom resource definitions, and we will require a controller to ensure that we can create, reconcile, and delete these resources in a programmatic manner. The second controller we're going to need is going to be the bootstrap provider. And this is the component that translates the YAML configuration into Cloud init script, and it will make sure to attach the instance to the cluster as a node. Now, this capability currently is supported by kubeadm, Talus, and recently EKS as well. And the third component that you'll require is going to be an infrastructure provider. And this is the component that actually talks with the cloud provider APIs and provisions the resources, such as instances, subnets, VPCs, security groups, you name it, all of them. Now, if you want to deploy to multiple clusters or infrastructure to multiple clusters, you will require a controller for each of them. So here is one-to-many, the relationship. And once you have all of these dependencies installed, you'll be able to provision the target clusters. And these are the target clusters that you deliver to your application teams, and they can deploy their products on top of. And these are going to be the clusters that your customers will interact with while consuming your services. Now, A very important thing about ClusterAPI is the fact that it introduces this concept of cluster as a resource. You can use YAML configuration to define your infrastructure as code. And this is very fundamental because of this YAML, we'll be able to use tools such as GitOps on top of it to fully automate its deployment. So I'm going to introduce these 5 custom resource definitions. The first one is going to be a cluster resource, and it usually takes care of the networking components for a cluster. We'll be able to choose the subnet for our pods and services and declare any DNS suffix. By default, with every single cluster, we're going to have a control plane associated with it. A control plane resource pretty much allows us to programmatically manage multiple machines that have the control plane label. And machine, it's a resource that is very similar to an instance. We'll be able to specify the version of Kubernetes, instance type. Again, you can attach any security groups to it, you name it. However, the vanilla ClusterAPI cluster just has a control plane. If you want to deploy applications, you'll require a data plane as well. Now, within ClusterAPI, the data plane is managed through a machine deployment. And I presume you're very familiar with Kubernetes, so machine deployment, it's very similar to deployment. It will pretty much make sure to roll out different configurations between machine set resources. Machine set, very similar to replica set. It will ensure that we have an amount of machine resources up and running at all time. And of course, we're going to have machines, which are going to be the instances. But in this case, our label is going to be a worker node. Now, this is how we can define how we want our infrastructure to look like. Here's where we can say that we want a cluster with 10 nodes, supposedly, 3 of them being a control plane, 6 of them being within the data plane. We can specify a lot of other options as well. This is just for simplicity. Now, to actually see how we can define this, I'm going to look at the cluster resource, and I'm going to look at 3 examples for AWS, GCP, and Tinkerbell. Now, here we have a cluster resource in the v1 beta 1 endpoint with the name demo cluster. In the specs section, you can see that I'm choosing a /16 for our pods, and towards the end, you can see that we have a control plane reference associated with it by default. However, I would like to draw your attention towards the infrastructure reference. Here is where we say that we want this cluster to be deployed in AWS. What it's actually going to do, underneath is going to pull all of the configuration that we've defined for our cluster to be deployed in AWS. So here we specify that we want it to be deployed in region EU Central 1, and we want to attach an SSH key name to our instances with the name default. Now, for simplicity, if you'd like to deploy the same cluster to GCP, these are going to be the changes required. So the cluster resource, you don't really need to change things. You just need to change your infrastructure reference to point to a GCP cluster. And by default, this is going to pull all of the configuration that is specific to GCP. Now, the region is going to be Europe West 3, very different region naming convention. In GCP as well, we have the concept of a project. So we associate our cluster with the project CAPI. And as well, we can attach a network, and we can specify it by name. In this case, default CAPI. Now, if we want to deploy this cluster with Tinkerbell, these are going to be the changes required. You can actually reuse your manifest, but it's a very standardized manner as well. So in this case with Tinkerbell, I'm just specifying the registry that I would like to pull my images that I would like to install on the base operating system. It can be a private or a public registry, depending on what kind of resources and requirements you have. Now, at this stage, we can understand that with ClusterAPI, we can deploy our infrastructure anywhere, especially different cloud providers. And we can do so in a unified manner as well. We can reuse the concepts and apply them to different providers. However, what happens if an organization does not want to use a cloud provider, a public cloud provider? What happens if they fully want to manage their infrastructure and they want to deploy bare metal? Well, in this case, we have Tinkerbell that saves the day. Now, Tinkerbell is an engine that focuses on provisioning of bare metal anywhere. Kubernetes is just a subset of it. Now, it was built by the Equinix team in 2019, and it was donated to CNCF in November 2020. So the actual status of Sandbox means it's still a greenfield project. It still requires a lot of functionality enhancement and a lot of diversity within the maintainership. So if you have a use for bare metal or a use for Tinkerbell, I definitely recommend to reach out to the team. And as mentioned, Tinkerbell tries to automate and reduce the time to deploy bare metal anywhere and automate majority of steps for you to have bare metal in the public cloud, on your data centers, or even on edge devices. And next, I would like to look at how Tinkerbell works. So to ensure that you can provision bare metal with Tinkerbell, you need 3 sets of configuration: the hardware configuration, template, and workflow. Hardware is pretty much your inventory. Here's where you say, I have 10 Raspberry Pis or 10 servers, the actual Tink. You have to make Tink server or Tinkerbell server aware of what you have. So the first one is going to be your inventory. Second one is going to be a template. And this is just a set of actions that you would like to implement or deploy on top of your bare metal machine. So think about a scenario where you want to install an operating system. You want to install any dependencies, any middleware, and to the end, you can install any applications that will be necessary for you to have a production-ready server. And the first set of configuration that you need is a workflow. And a workflow pretty much attaches a hardware to a template. And this is going to be the case if you have a multi-fleet or like different strategies to deploy your application. So you can say that on these 5 servers, I want to install Linux and their respective dependencies. However, on this one, I want to install Windows and any other dependencies that we have. So here is where you can actually define different configurations for different strategies to deploy your application to prod. Now, once we have all of this configuration, we'll need to talk with the Tink CLI. We'll actually use Tink CLI to send all of this configuration towards the Tink server. The Tink server can run anywhere within your local machine if you are doing a demo or trying to POC the project, or it can run anywhere within your environment. So what's going to happen, once you have your inventory, a bare metal hardware machine, we're going to have the template run all the actions on top of that bare metal machine. We have an operating system, all of the dependencies, and by the end, we should have a server or a VM in the state that we wanted it to be. Now, with Tinkerbell, we can provision bare metal, simple bare metal. However, what happens if we want to provision a bare metal machine that's going to be a Kubernetes node? Well, in this case, we have this coalition between ClusterAPI and Tinkerbell. And this is going to be resulting with APT, which is the ClusterAPI provider for Tinkerbell. You're going to hear that quite a bit. So let's see how these tools work together. How can we provision Kubernetes on bare metal? Now, there are going to be 3 sets of configuration that I'm going to focus on. What we need from the Tinkerbell side, what we need from the management cluster, and what's going to result with the target cluster. This is going to be our end infrastructure. So on the Tinkerbell side, we still need our hardware. We still need to make Tink aware of what kind of servers we have available, so we can specify our inventory. And we still need our Tink server to be up and running somewhere to ensure that we have connectivity to this hardware. Now, on the management cluster, this is going to be the ClusterAPI side. The first thing we're going to need is going to be the Tinkerbell provider. So the infrastructure reference, the infrastructure reference is going to be Tinkerbell, and we'll need a provider for Tinkerbell to ensure that we can have all the functionalities that comes with it. Another thing that we need is going to be our YAML manifest that's going to define our infrastructure as code. So those 5 custom resource definitions that I mentioned. So here you can say I want a cluster with 4 nodes, 3 to be in the control plane, 1 to be in the data plane. And another thing, quite important, we need a hardware YAML. Now, here we need to make ClusterAPI aware of what kind of inventory, what machines we can use to deploy Kubernetes on top of. So if you have 10 Raspberry Pi machines, you can say that I want only 5 of them to be part of a Kubernetes cluster. So you need to make ClusterAPI aware of what's available just for Kube. Now, once we have all of these dependencies available, Tinkerbell, or ClusterAPI provider for Tinkerbell, already has a set of predefined templates and workflows, so you don't have to write them, they're already available. So if you want to provision a new machine, Tinkerbell provider is going to pretty much take the hardware, take all of the actions within the template, install them on top of it, to the point that you're going to have a server with all the binaries, Kubernetes binaries installed on it. So you're going to have kubelet, you're going to have cert manager, you're going to have connectivity to the control plane, and by the end, it's going to be part of the cluster. Now, let's take a step back. When we talked about ClusterAPI, we talked about the importance of having this concept of cluster as a resource. But more importantly, we can use YAML manifest for that. And the thing is, we can automate the deployment of that YAML manifest. Now, for anyone new to Git, it's pretty much a principle that has Git repositories as the source of truth for your application, and in our case, for our infrastructure. And this means that by default, we're going to have a PR-based rollout. That means that the delta between your local environment and production is just 1 PR away. Another thing that we have with GitOps is the fact that we have automatic reconciliation. So the GitOps tool is going to watch your repository, and if new commits are identified, they're going to be extrapolated and applied to the cluster straight away. But more importantly, we're going to have a version state of our cluster. That means that we have different historical data points that we can revert to very easily. Especially if you are in an incident, you can use a couple of Git commands to revert to a green state or a stable state that you are aware of. And within the cloud-native space, the GitOps principle is very well established by tools such as Argo CD and Flux, both of which are incubating projects at the moment. But both of them very, very pushy in terms of their graduation process. So hopefully you're going to see them with the graduation status, showcasing their maturity and stability within the community. Now, where exactly we can introduce GitOps within our infrastructure provisioning? And this is where I'm going to make abstraction of Tinkerbell. Let's think about we want to deploy a cluster with ClusterAPI and to introduce automation on top of it. So by default, on the management cluster, we're going to have our controllers installed. We know that. We're going to have our YAML manifest, which is defining our infrastructure as code. Now, those YAML manifests, by default, we can store in Git. And what we can have on top of that is Argo CD watching the Git repositories for any change. If we introduce any change to our infrastructure, Argo CD is going to apply them, and the end result is going to be seen in the target cluster. Now, very optional, you can introduce a template manager. In this case, I've chosen help to just parameterize some of the values within the manifest. So in this case, I want to parameterize the version of Kubernetes. It's going to be 124.0. I want to parameterize the amount of control planes. In this case, I'm going to have 3 of them, and I'm going to have only 1 data plane machine, or 1 worker node. Now, again, the Helm part of it is completely optional. However, going back to the metric we defined at the beginning of the presentation, we're never going to have 1 cluster. We're going to have multiple clusters. So it makes sense for us to parameterize as much as possible. And I think this is going to be the demo that I would like to introduce. So going back a bit, what I'm going to have a management cluster, and I'm going to have a target cluster already deployed. I'm going to use AWS for simplicity. I would love to have a demo on bare metal, but carrying a couple of Raspberry Pis, it's a bit more challenging between countries. So I will showcase how can you automate the deployment of your infrastructure using ClusterAPI and GitOps, but the same principles can be applied with Tinkerbell. So this is a very important concept. So hopefully everything is running, and I still have internet connection. Cool. Can everyone see the screen? Cool. I'm going to go through everything here. So as mentioned, on the management cluster, I'm going to have the ClusterAPI controllers installed. And we can see them just over here. So I'm going to have the Kappa actually stands for ClusterAPI provider for AWS. Because I'm going to use AWS for the demo, I'm going to have that particular infrastructure provider. Here we have kubeadm for our Bootstrap provider. And we have our copy controller to ensure that we can create and reconcile any ClusterAPI-specific CRDs. As well, on the management cluster, I have Argo CD installed because I'd like to automate the deployment of our infrastructure. Cool. Now, let's go back on this screen. Can everyone see what's going on here? I'm going to go for all of this as well. Now, I've already deployed a AWS cluster with 4 nodes, 3 of them being in the control plane, 1 of them being a worker node. And I've deployed this before the presentation, mainly because it takes around 5 minutes to have everything ready, because you have to provision a VPC, which takes a bit of time within AWS. But what we have here is, this is going to be, so these 3 machines that you see here running 124.0, they are part of the control plane. And here, I have an MD. MD here stands for machine deployment, which is pretty much our data plane. So we have only 1 machine being our worker node. So on the top side, you can see our management cluster. On the bottom side, you can see our target cluster. So if I query the nodes in target cluster, I can see that I have 3 control plane machines, and 1 of them is going to be a work node. So this is what we have at the moment. Now, let's go back to our template managers. So in this case, I'm using Helm to parameterize our YAML manifest that we've seen on the slides, such as cluster CRD or machine deployment CRD. And I've mentioned I want to, can everyone see this one? Can I make it bigger a bit? So in this case, I would like to parameterize the version of Kubernetes, amount of replicas for the control plane, and data plane. So how it's actually going to look, just for anyone new to Helm, make sure that everyone is on the same path. If I go to the cluster YAML, similar thing that we've seen on the slides. Nothing different. We have a /16 for our pods, we have a control plane reference, and an infrastructure reference pointing to AWS. Going to machine deployment. Here is how we can parameterize, and we actually pull the values that we define for a Helm input file. So here we can pull the value for our replicas in terms of the data plane and the version of Kubernetes. So just kind of a very quick overview of how Helm gets values and reconstructs the manifests. Now, if I would like to change my infrastructure, if I want to introduce any changes, in this case, I'm going to change the amount of replicas that we have for our data plane. The only changes I need to do is within the Helm chart. I don't need to touch the manifest straight away. So I'm going to go to the values demo file, similar that we've seen on the slides. And I would like to increase the amount of replicas from 1 to 4. And because this is using GitOps, I just have to use a git command to apply these changes. So I'm going to use a git commit for a very meaningful demo message. And I'm going to do a git push straight away to master. Now, I already have Argo CD up and running. This is going to be very overwhelming, what's going on here. But as you can see, I have a cluster resource, a machine set, and that takes care of 2 machine configurations. Now, if I click refresh here, I should be able to see that I'm out of sync. My infrastructure is out of sync. And I can actually see that if I click on the commit tag, I'll be able to see that I've changed the amount of replicas from 1 to 4. And what I need to do, well, with Argo, we can actually have automatic and manual synchronization. In this case, I choose manual because I want to review my changes before applying them. I'm happy with the changes. I'm just going to hit async. And this can be automated as well. Now, going back to our terminal, we can see that we already have 3 machines. This is on our management cluster already being provisioned. And ideally, towards the end, we should see changes to our infrastructure target cluster as well. Now, if I'm going back, I can actually go to AWS and see our instances. If I hit a refresh, if everything, oh God. OK, hopefully, you cannot see my password. Ooh, OK. Oh, butterfingers now. No. Live demos. Oh, that was not good. It's a Z, it's a W. Never mind, I give up. Am I doing this right? Is this right? Or is it a V? OK. It's not a V. I am sorry, it's not a V. We failed at capture entry, like I'm not a human, apparently. Oh. Anyway, let's pause the AWS side. We can view everything within our terminals. Come on, we can do this from the terminal side. So what we can actually see here is 85 seconds ago, we can see that we have AWS machines. We can actually have the link to it. So we know it's provisioned. We will be able to see the new instances initializing within AWS. Hopefully, after the talk, I can log in. And anyone curious, I can show you the AWS dashboard. And another thing, we can see changes to our target cluster. So we can see that we have 3 nodes, which are with the worker node label. And the most important thing, we didn't have to apply anything manually. Like, we had to review the changes because I've chosen this strategy for Argo CD. But ideally, all of these changes should be applied automatically. So you can fully have hands-off when it comes to infrastructure provisioning. Now, the demo was fine. The AWS was not so fine. I'm just going to go back to my slides. Actually, for anyone curious, I have a recording of it, so you can definitely see all the dashboards as well. Now, the most important thing is that we can use the same principle for our bare metal provisioning, because with ClusterAPI, deploying our infrastructure to different providers is similar. We have the same controllers and the same functionalities that are going to take care of our provisioning. So if you want to provision bare metal or Kubernetes on bare metal using Tinkerbell, again, you're going to need 3 sets of configuration. On the Tinkerbell side, the management cluster and the target cluster is going to be our result. Now, again, on the Tinkerbell side, we need to have our inventory. We need to say that we have this amount of machines available. And we need to make Tink server aware of them and to actually ensure that they have connectivity as well. Now, on the management cluster, going back to all of the prerequisites, this is going to be a very good recap. We're going to have all of our controller managers, so for the ClusterAPI CRDs, for the bootstrap provider, and infrastructure provider, which is going to be a Tinkerbell provider now. Our YAML manifest, our infrastructure as code, now is going to be managed by a Helm chart. So you can use, again, Helm. It's completely optional, or you can use the full manifest and just do a kubectl apply. That's going to work as well. And you're going to have Argo CD watching those Helm charts. Now, if you want to provision a new machine, a Tinkerbell machine, using ClusterAPI, you can do changes to your Helm chart. Argo CD is going to pick up those changes and apply them to the cluster, to the management cluster straight away. Now, in the management cluster, we have the Tinkerbell provider up and running. And it will actually see that it needs to provision a new machine that's going to be a Kubernetes node. It's going to take one of the machines, which we defined in the hardware YAML, and it will install the Kubernetes binaries on top of it as such. So by the end of it, we should have a machine that's going to be part of the cluster node with all of the connectivity already installed. And for anyone who still doesn't understand the kind of overlap between these tools, if you want to provision bare metal, Tinkerbell is going to be your solution. If you want to provision Kubernetes on bare metal, then you have to introduce ClusterAPI into the picture with a Tinkerbell provider. And if you fully want to automate the deployment of your infrastructure or your YAML manifest, you can use Argo CD. They can deploy your infrastructure and can deploy any other applications that you have within your cluster. And the thing is, all of this intertwinement between these different tools has been possible because of the building blocks principles within the cloud-native space. And it even focuses on optimizing the way we deploy bare metal in an automatic, declarative, and interoperable way. Now, without saying, we are hiring. If you'd like to work at Apple and to actually bring the cloud-native expertise, go to jobs@apple.com. You can work with my team or any other teams within the Apple Cloud Services or ACS. If you have any questions in regards to any role, please reach out. I'm going to make it as easy for you to make sure that you apply and are successful throughout your process. Now, for anyone interested in ClusterAPI more in depth, I've written a lot of blog posts around it, especially how you can use ClusterAPI in GitOps and fully automate the process. I'm talking about ClusterAPI upgrades using GitOps. Just go to the Medium blog post, and you'll be able to find more details. And if you have any questions, I'm more than happy to answer them after the talk, or you can reach out to me on social media such as Twitter and LinkedIn. And here is a QR code towards the Cloud Native Fundamentals course. It's completely free. You don't have to pay for it. But if you have anyone interested in pursuing a cloud-native career and they're unsure, I would definitely recommend that. This is Katie Gamanji, and I look forward to seeing how you can shape the cloud-native ecosystem. Enjoy the rest of the conference. Thank you.